If you've ever tried to learn programming, you know the feeling, right? That frustration, the confusing jargon, the errors that make no sense. It can feel like you're just hitting a wall over and over. But what if the problem isn't actually the code? What if it's the way we're taught to think about it? Today, we're going to dive into a book that totally flipped the script on learning to code, Think Python.
And this whole thing really starts from a place of shared frustration. The author, Downey, he was a teacher, and he was watching his students struggle, big time. They were either failing, or the ones who did pass weren't really getting it. This quote just captures that feeling perfectly, a feeling a lot of us can probably relate to.
So picture this. It's 1999. Downey is teaching an Intro to Java class, and he's seeing this problem firsthand. He realizes that the old-school, traditional way of teaching just isn't working. So instead of just tweaking a few things, he decides to do something, well, pretty radical. He's going to write a whole new textbook from scratch.
And this new book wasn't just, a different set of exercises or examples. No, it was built on a completely different philosophy. The goal wasn't to just drill syntax into students' heads or bury them in dense theory. It was about changing the way they think. And these are the core principles that he built it on. What's so brilliant is just how simple and totally student-focused they are. First, keep it short. He figured it's way better for a student to actually read 10 pages than to get overwhelmed and not read 50. Next, cut down on the jargon. And if you have to use a technical term, define it right then and there. Then, build things up gradually. Take those really tough topics and break them down into small, manageable steps. And maybe the most important one, focus on programming as a skill, the art of problem solving, not just memorizing the rules for one specific language.
So Downey writes this book for his Java class, but what happens next is where the story gets really interesting. In his own words, it's the cool part. It's a story about how collaboration and community took his original idea and turned it into something way bigger than he ever imagined.
Okay, so the journey of this book is just fascinating. It starts in '99 as that Java textbook. But then, in 2001, a high school teacher named Jeff Elkner finds it. He loves the philosophy, so he takes it upon himself to translate the whole thing into Python for his own students. He sends it back to Downey, who then decides to teach with the Python version himself in 2003. And he's just blown away. The students learned more, they had more fun, they built cooler stuff, and that open, collaborative spirit is still alive today. Over 100 people have contributed to making the book what it is.
And get this is my favorite little piece of trivia about this whole story. How did the author, Downey, learn Python himself? Well, he learned it by reading his own book after Jeff Elkner had translated it. I mean, how cool is that? It just goes to show what a unique, community-driven project this was right from the start.
So what does it actually mean to think like a computer scientist? Well, the book's big idea is that the single biggest mental leap you have to make is learning to communicate in what's called a formal language. And trust me, it is a world away from the natural language we all use every single day.
Think about it. Natural languages like English, they're kind of messy, right? They're full of ambiguity and repetition. We use metaphors and idioms all the time. If I say it's raining cats and dogs, you know I'm not talking about animals falling from the sky. But formal languages like Python are the complete opposite. They are designed by people to be totally precise, super concise, and 100% literal. Every single statement has exactly one meaning, period.
And this quote from the book just nails it. A computer program doesn't get your jokes or your sarcasm. Its meaning is right there on the surface. You can understand it completely just by looking at the words, the tokens, and the structure. Mastering this literal way of communicating, that's the real key.
But Think Python isn't just about these high-level ideas. It actually gives you a practical toolkit for your brain, a bunch of concepts and mental models to help you start tackling problems like a real programmer.
Let's start with a word we all know, a bug. The book explains that these programming errors aren't just annoying failures. The process of hunting them down, debugging, is actually a core skill. You have to think of it like detective work. It's a puzzle to be solved, and it's something anyone can get good at.
So how do you get into that mindset? First, just accept it. Everyone makes mistakes. It's part of the process. Then, be systematic about it. Think like a scientist. Make a guess, a hypothesis, about what's wrong, and then run a test to see if you're right. A fantastic technique for this is debugging by bisection. You basically check a value right in the middle of your program. That tells you if the problem is in the first half or the second half. It lets you zero in on the error so much faster. And those little print statements you add to see what's going on, that's called scaffolding, like the temporary structure on a building that helps you see inside while you work. Okay, next up,
Functions. The book uses this brilliant metaphor to explain them. Think of calling a function like taking a detour. Your program is cruising along a main road, then it sees a function call and thinks a quick detour to run that specific block of code. Once it's done, it comes right back to the main road, exactly where it left off. It's such a simple and powerful way to keep your code organized.
And now for the big one, algorithm. This word sounds so intimidating, right? But it's really not. The book explains that an algorithm is just a mechanical process. It's like a recipe. It's a simple set of rules you can follow to solve a certain type of problem. And here's the key part. You don't need to be a genius to carry it out. You just follow the steps.
And this really brings us to the ultimate goal of Think Python. It's not just about learning to write code so a computer will do what you want. The true goal is to absorb a new, more powerful way of thinking and solving problems in general. A skill that is useful way, way beyond your computer screen.
So I'll leave you with this final thought. What if we just reframed this whole idea of learning to code? Maybe it's not about becoming an expert in Python or Java or whatever the language of the day is. Maybe it's about becoming fluent in clarity, in logic, and in a structured way to solve any kind of problem. What would that change for you?